Hello students, how are you all? I hope that you all are good. As we know, the series of motion in a plane is going on and we are successfully finished the 15 lectures, right? So in a previous lecture that we are discussed about motion of the boat along a line of reverse flow. Okay, so this is the concept that we are discussed in our previous lecture and we are discussed about the formula of downstream and upstream. After that we are discussing some example problems, right? So this is what we are exactly discussed in our previous lecture, right? So in today's lecture that we are going to discuss about one of the important concept, that is a river, swimmer or boat problems. River, swimmer or boat problems. Okay, so important concept. Maybe you have some small confusion on this concept when you are doing the problems, but today I am going to give a complete clarity on this concept, right? Are you ready? Shall we start the session? Okay. So my name is Rakesh Kanaganti. Welcome to our beautiful physics channel, Rakesh Sir Physics, right? Okay. So what is the chapter going on? The chapter is motion in a plane. Motion in a plane, right? So this is a class number 16, right? Class number 16. So what is today's concept? And today's concept is river, man, that means a swimmer or boat problems. Problems. Okay, right. Right. So I'm just going to divide this concept into two parts. Okay, right. Okay, sir. Right. So the first concept of today's lecture, that is a swimmer or boat, swimmer or boat has to cross the river, has to cross the river over a shortest distance, over a shortest distance. So this is our first concept. Okay, sir. So what is our second concept? Our second concept is the swimmer or boat has to cross the has to cross the river in the shortest time. In the shortest time. So these are the two concepts. So one more concept is there, that is a small concept. Okay, have a look. These are the two important concepts that we have. Right. So have a look. What is our first concept? Swimmer, boat has to cross the river over a shortest distance. Boat or swimmer has to cross the river over a shortest distance. Right. I'm taking the river. Have a look. Let us consider. This is a river. Okay. And the river is floating in this direction. River is floating in this direction. La 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 la. Okay. Allah, it is floating in this direction. Now, have a look. The velocity of river, the velocity of river. I am taking VR. VR be the velocity of river. And as we know that the river is floating on the surface of ground. The river is floating on the surface of the ground. So now velocity of river with respect to ground. Velocity of river with respect to ground. Now we need a swimmer or boat, right? Here I am taking one swimmer. Initially, the swimmer is at a point A. Initially, the swimmer is at a point A. So, whenever we are discussing the concept of relative velocity, relative displacement, and relative acceleration, what we need? We need one common frame. We need one common frame. That is S frame, ground, earth, observer. Already we are discussed in a concept of relative displacement, relative velocity, and relative acceleration. In the first session of that concept, I told you that. So whenever we are dealing the relative velocity concept, relative acceleration concepts, we need one common frame, that is observing frame. Okay. So here I am taking the observer. Here I am taking the observer. Now this observer is inside the frame of reference. Now this observer is inside the frame of reference. Now he is observing the swimmer. This observer is observing the swimmer. Now what happened? With respect to this observer, whatever the path of the swimmer is there, it is look like a straight line path. It is look like a straight line path. Okay, so what is this? Velocity of swimmer with respect to observer. Observer is nothing but S frame, earth frame, ground frame. Velocity of swimmer with respect to observer is what? It is a shortest path. Let us consider the width of the river. Let us say D. D be the width of the river. Now, with respect to observer, when the observer is inside the frame of reference, whatever the path of swimmer is there, it looks like a straight line path. Are you getting? Because he is inside the frame now. So with respect to him, the velocity of river with respect to ground becomes zero. Becomes zero. That means whenever the water is floating like this, now you are sitting inside the water on the ground and you are observing the observer. So he is swimming like this. So the path of the swimmer with respect to the observer is like a straight line path because he is inside the water. He is inside the water. So with respect to the observer, the flow of water is zero. The velocity of flow of water is zero. So that's why. So the path of the swimmer is look like a straight line path. Have a look. So the observer is inside the water and the swimmer is swimming like this. So in a straight line path. Are you getting any doubts? Okay. So now in a second case, in a second observer is outside the frame of the reference. Outside the frame of reference. Now he is on the surface of the ground and he is observing the situation. He is observing the situation. Now he is standing at the bank of river and he is observing the river. So with respect to the observer, this river is moving with some velocity. He can clearly observe that. So the river is moving with a velocity of river with respect to ground. So now again he is observing the swimmer. He is observing the swimmer. So now the swimmer started moving. Now the swimmer started swimming. So now with respect to the observer who is standing on the bank of river, so with respect to him, this river is flowing with certain velocity and this swimmer is also swimming with certain velocity. Now this observer is thinking, if this person is swims in this direction, is started swimming in this direction by making an angle theta with the baseline or straight line. So what happened? The velocity of river is in this direction and the swimmer started moving in this direction. So what happened? With respect to the velocity of this river, with respect to the velocity of river, this swimmer is also shifted his path because this velocity of river, that means the flow of river takes him away from the baseline. Takes him away from the baseline. Have a look in that gift in that graphics. So the persons are moving with the persons are moving with the flow of river. Have a look. Okay, so the same thing happened here. So with respect to the flow of river, this swimmer is also take away from the baseline. So he is moving like this, and he reached the another end of the bank at this place when he started in the direction of flow of river. Okay, this is a one case. Now he started moving in this direction. Let us consider he started swimming or moving in this direction. So what happened? Now again this is also making an angle theta with the baseline. Have a look. The velocity of flow of river is in this direction. The swimmer is moving by making an angle theta with this baseline in opposite to the velocity of river. So what is this? Velocity of swimmer with respect to water is opposite, some opposite direction by making an angle theta with the baseline. Now he is swimming in this direction. So velocity of river in this direction and he is opposing the velocity of river with respect to ground and he is swimming like this. Now he reached the other end of the bank of river. So have a look. In these two cases, what is the shortest distance? Absolutely, this path gives the path of the swimmer to cross the river over a shortest distance. Are you getting? Right. So I'm just going to rough all these things. And So well, the river is moving in this direction with certain velocity of river with respect to ground, and here is a point A, and the swimmer. So this is the path of a swimmer whenever the observer is inside the frame of water. So velocity of swimmer with respect to ground. Now whenever the observer is outside the frame of reference, so now whatever the path of the swimmer is there, that is this. So velocity of swimmer with respect to water by making an angle theta with the baseline. Let us say this is a point A, and this is point B, and this is what, point C. And the width of the river, let us say D be the width of the river. Okay, right, right. So from figure we can write, have a look. This is what velocity of swimmer with respect to water and velocity of river with respect to ground. These two velocity vectors are in order. Have a look. These two are in order. So we can write velocity of swimmer with respect to water plus velocity of river with respect to ground. This is equals to, and this vector is in reverse order with respect to these two vectors. Are you getting? So with respect to these two vectors, this vector, velocity of swimmer with respect to ground is in reverse order. So the resultant of these two vectors is given by the third vector, which must be taken in reverse order. Already we are discussed in a triangle law of vector addition. Okay, so the same thing here I am written. Okay, sir. So this is a first one. So the second one, have a look. From this diagram, it is clear that here one right angle triangle is formed. One right angle triangle is formed. So what is this? Velocity of swimmer with respect to ground, and this is what? Velocity of swimmer with respect to water, and velocity of river with respect to ground. And it is a right angle triangle. So this is 90 degrees. This is what? Hypotenuse, and this is side 1, and this is side 2. So from this right angle triangle, it is clear that, so the hypotenuse square, we can write a Pythagoras theorem. Hypotenuse square is equals to side 1 square plus side 2 square. Okay, this is the formula. So from this formula, it is clear. Hypotenuse square, velocity of swimmer with respect to water whole square is equals to, so side 1 square, velocity of river with respect to ground whole square plus velocity of swimmer with respect to ground whole square. Okay, so if you wanted to find the velocity of swimmer with respect to ground, velocity of swimmer with respect to ground whole square is equals to, so if this term comes to this side, it becomes velocity of swimmer with respect to water whole square minus velocity of river with respect to ground whole square. Okay, so if square went to that side, it becomes root velocity of swimmer with respect to ground is equals to under root of velocity of swimmer with respect to water whole square minus velocity of river with respect to ground whole square. Okay, so this is the formula for velocity of swimmer with respect to ground. So the third formula, from figure, again I am taking the figure. It is clear that, from figure it is clear that, so we can write cos theta as, so cos theta is what? Adjacent side by hypotenuse, adjacent side by hypotenuse. Then cos theta is equals to, so have a look, here we have theta. So adjacent side, along theta side, adjacent side. What is the adjacent side? VSG divided by hypotenuse. What is hypotenuse? Velocity of swimmer with respect to water. Velocity of swimmer with respect to water. Okay, and again, if you want to write the equation for sine theta, then sine theta is equals to what? Opposite side by hypotenuse. So from figure, what is the opposite side? The side which is an opposite to an angle theta. So that is VRG, velocity of river with respect to ground, divided by what is hypotenuse? VSW. VSW. So sine theta is equals to velocity of river with respect to ground divided by velocity of swimmer with respect to water. So this is sine theta, and this is the value of cos theta, right? So the fourth formula. So the fourth formula I am going to write, that is a time taken, time taken by swimmer, time taken by the swimmer to cross river, to cross the river of width d, width d, to cross the river of width d. So we have to find the time taken by the swimmer to cross the river of width d. So in general, what is the time? So time is nothing but distance by velocity. In general, time is nothing but distance by velocity. Now what is this? Velocity of swimmer with respect to ground, and it is in a plane. It is in a plane. So it has a two rectangular components. Have a look. Along theta side, we get VSW cos theta, VSW along theta side, and perpendicular to this you will get VSW sin theta along this direction. Along this direction you will get VSW cos theta. Are you getting? Along theta side VSW cos theta and perpendicular to this VSW sin theta. So what we are finding? We are finding taken by the swimmer to cross the river. So time is nothing but what? Distance by velocity. Now here the velocity of swimmer with respect to water has two components. One is VSW cos theta and another one is VSW sin theta. Now which component we have to take? This one or this one? So whenever you are finding the time, always you must take the component of velocity of swimmer which is perpendicular to. Always take the perpendicular component of velocity to velocity of river with respect to ground. So always we should take the perpendicular component of velocity to velocity of river with respect to ground. So whatever the velocity here you are taken, this must be always perpendicular to the velocity of river with respect to ground. Have a look. This is the velocity of river with respect to ground. And what is the perpendicular component for this? So VSW cos theta. So distance is d, width of the river, divided by velocity. What is the velocity? VSW cos theta. Are you getting? So now this gives the time taken by the swimmer to cross the river. Time taken by the swimmer to cross the river. Okay, right. And if you want to find the minimum time, so minimum time can be given by, so T minimum is equals to distance by velocity of swimmer with respect to water into cos theta. In general, we got this formula. Time. For time, this is by VSW. What is cos theta? Cos theta is nothing but VSG by velocity of swimmer with respect to ground by velocity of swimmer with respect to water. So velocity of swimmer with respect to water, velocity of swimmer with respect to water get cancelled out, and we get velocity of swimmer with respect to ground. So this gives the minimum time taken by the swimmer to cross the river. So this is what? General time. This is what? Minimum time. So if you wanted to find the minimum time, so just you have to take the width of the river divided by velocity of swimmer with respect to ground. And if you wanted to find the general time, so they ask, what is the time taken by the swimmer to cross river over a shortest distance? T is equals to d by VSW cos theta. What is the minimum time taken by the swimmer to cross the river over a shortest distance? T minimum is equals to distance by direct. You have to write velocity of swimmer with respect to ground. That's it. Okay. So here I am writing the formulas. So the fourth formula, time. T is equals to, we got what ma? Distance. That means width of the river by VSW cos theta. And we got our minimum time. T minimum is equals to distance by velocity of swimmer with respect to ground. Velocity of swimmer with respect to ground. Okay. Then. So pause the video and write all these things. I'm going to rub this part now. So pause the video and write the notes. I hope that you got the clarity over this concept. Okay, shall we discuss that? Okay, pause the video and write the notes. 3, 2, 1, go. Right. So have a look. The second case. Swimmer or boat has to cross the river in a shortest time. That is our second case. So right, I'm taking the river. So let us consider this is a river. Okay, sir. Let us consider the width of the river is d. D be the width of the river. Now the direction of flow of river is this. Okay. Now the river is flowing in this direction. As we know that the velocity of river, whatever the velocity of river is there, that is velocity of river with respect to ground. Okay, sir. Now initially the swimmer is at a point A. The swimmer is at a point A. Now the observer is in the frame of reference. That means the observer is in the water. Now he is observing the swimmer. Now whatever the path of this swimmer is there, that is a straight line path with respect to the observer. So now whatever the path of the swimmer is there, that is what, ma? So that is straight line path with respect to the observer. Okay, when he is in the water, in the frame of reference. So whatever the path of the swimmer is there, that is a straight line path. Are you getting? Okay, sir. Now, whenever the observer is on the surface of ground, now he is observing the swimmer. With respect to the observer, the path of the swimmer is like this. Okay, so he feels that, observer can feels that the swimmer can be moves like this. The swimmer can be moves like this by making an angle theta with the vertical line. By making an angle theta with the vertical line. Although the swimmer moves from point A to point B in a straight line path, but with respect to the observer who is standing on the ground, so with respect to him, this is the path of the swimmer. This observer who is standing on the surface of the ground feels that this swimmer is moving with respect to the flow of river. Moving with respect to the flow of river. That's why this flow of river can drifted him point B to point C. Drifted him to point B to point C. Okay. So are you getting? Right. Very good. Now what is this? This is the velocity of swimmer with respect to ground because he is observing. Now what is this? Velocity of swimmer with respect to water. Velocity of swimmer with respect to water. Are you getting? Any doubt? Okay, very good. So whatever the distance between point B and point C, that is x. Okay, this is called a drift. X is called what, ma? Drift. X is what? Drift of a swimmer. Drift of a swimmer due to flow of river. Due to flow of river. Okay, x is what? Drift of a swimmer due to because of flow of water. Just the observer feels that who is standing on the surface of the ground, he feels that this flow of river drift the swimmer from point B to point C in the direction of flow of river. In the direction of flow of river. That is called what? Drift. X is called what, ma? Drift. Have a look. Now I am going to write the formulas. First one, from figure. So, what is this? Velocity of swimmer with respect to water plus velocity of river with respect to ground. Both are in order VSW plus velocity of river with respect to ground. Both are in order. And this term and this term. So, velocity of swimmer with respect to ground is in reverse order. Therefore, the sum of these two given by this one. Okay, sir. Okay, right. And from right angle triangle. Have a look. This is what? Velocity of swimmer with respect to water. Velocity of river with respect to ground. What is this? Velocity of swimmer with respect to ground. So this is 90 degrees. Then hypotenuse square is equals to side 1 square plus side 2 square. Then velocity of swimmer with respect to ground. Velocity of swimmer with respect to ground. Whole square is equals to velocity of swimmer with respect to water whole square plus velocity of river with respect to ground whole square. If square went to that side, it becomes velocity of swimmer with respect to ground is equals to under root of velocity of swimmer with respect to water whole square plus velocity of river with respect to ground whole square. So this is what? The resultant velocity of swimmer with respect to ground. Right. So this is the second one. First one, second one. Have a look. The third one. Right. So what is the third one? Time taken. I'm going to find the time taken to the swimmer to cross river in a shortest time. So how can we? So t minimum time is equals to what, ma? T minimum is equals to what? Distance by the perpendicular component of velocity. The perpendicular component of velocity for the velocity of river with respect to ground. So the perpendicular component of velocity for the velocity of river with respect to ground is what, ma? Velocity of swimmer with respect to water. Velocity of swimmer with respect to water. So this gives what? Time minimum. This gives what now? T minimum to cross the river for the swimmer. So the fourth formula, right? So the fourth formula, I wanted to write the equation for drift. So drift x is equals to, drift is nothing but what? It is a simply a distance. It is what? It is a distance. In general, what is the formula for distance? Distance is nothing but velocity into time. So have a look. Here we have three velocities. Which velocity we have to take? Have a look. This swimmer can be drifted. This swimmer can be drifted due to because of flow of water. Due to because of flow of water. Then which velocity you have to take? You have to take the velocity of river with respect to ground, because this swimmer can be drifted due to because of this velocity into time. Time is nothing but T minimum. So that is equals to VRG into minimum time. What is the minimum time? Distance by velocity of swimmer with respect to water. What is this? This is equation for drift. The formula. Have a look. Fifth one. If I want to find the displacement of a swimmer, displacement of swimmer. Have a look. What is this? This is the width of the river. Let us say this is D. D is the width of the river. So what is X? X is nothing but drift of the swimmer. Now let us consider this is a displacement. S be the displacement of the swimmer. Okay. So S be the displacement of the swimmer. So this is what? Width of the river. This is X, drift of the swimmer. And what is this? This is a displacement. So S bar. Okay. So from this figure, it is clear that again it is a right angle triangle. Then hypotenuse square is equals to, that means displacement square is equals to side 1 square plus another side square, d square plus x square. Now the displacement vector S bar is equals to under root of d square plus x square. D square plus x square. Are you getting any doubts? So with this, all the formulas are completed. All the formulas are completed. So one more small concept is there. After that, we will do the problems. Okay. Any difficulty is there? No difficulty is there, na? So only, although you are understood the concept or not, just keep it aside. Only one thing you should remember in your mind: whenever the person has to cross the river over a shortest distance, always, if you see the word shortest distance, just to take the path of the swimmer is in this direction, and whatever the velocity of swimmer is there in this direction, that is velocity of swimmer with respect to water, and this is velocity of swimmer with respect to ground. Whenever, if you see the word, so the minimum time taken for the swimmer to cross the river, just blindly you draw the diagram like this. Okay, you have to draw the diagram like this. So what is this? Velocity of swimmer with respect to ground, velocity of swimmer with respect to water. If you practice these two diagrams, then you can easily write all these formulas. Okay, any difficulties there? No difficulties there, na? Right, I'm going to rough the board. Please pause the video and write the notes. Pause the video and write the notes. 3, 2, 1, go. Right. So have a look. The last concept of today's lecture. Sir, this is the last concept of today's lecture. Yeah, class is over. So don't get excited. Next we have problems. Okay. Right. Sir, what is this, sir? This is a river boat problems, sir. Okay. So here I'm taking the river. Right. As we know that the width of the river is how much? D be the width of the river. Right. So now this river is floating in this direction. In this direction the river is floating. So what is this? Velocity of river with respect to ground. It is floating in this direction. Okay, like this. La 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 la. Okay. So at a point A there is a swimmer. At a point A there is a swimmer, and he started moving, or he started swimming in this direction. He started swimming in this direction. So what is this? Velocity of swimmer with respect to water. He started swimming in this direction. So by making an angle theta with the vertical line, by making an angle theta with the vertical line, right? This is an angle theta. So after some time, he reached the other end of the bank of a river at a point B. He reached the other end of a bank of the river at a point B. So now what is this? This is the velocity of swimmer with respect to ground. Okay, so I'm just extending this line like this. Okay, so this is the extended line. What is this? Velocity of swimmer with respect to water. Velocity of swimmer with respect to water. Have a look. A person is at a point A, and he started swimming with a speed v as the velocity of swimmer with respect to water by making an angle theta with vertical. Okay, now the time taken to reach other end of a bank, of river, for swimmer is. So what is time? Simply time is nothing but distance by velocity. Distance by velocity. Which velocity we have to take? We have to take the perpendicular velocity for velocity of the river with respect to ground. We have to take whatever the velocity we are taken. That velocity must be perpendicular to the velocity of river with respect to ground. So have a look along theta side. This is what velocity of swimmer with respect to water. So along theta side, you will get VSW cos theta. Velocity of swimmer with respect to water into cos theta. Now perpendicular to this, you will get VSW sin theta. Along theta side, you will get VSW cos theta, and perpendicular to this, VSW sin theta you will get. Now what we need to find the time? So time t is equals to distance by velocity perpendicular for velocity of river with respect to ground. So with respect to velocity of river with respect to ground, what is the perpendicular component? VSW cos theta. So P is equals to, what is the distance? Distance is nothing but width of the river divided by VSW cos theta, velocity of swimmer with respect to water into cos theta. So this is the time taken for swimmer to reach the other end of the bank. So already I told you that. So what is this? This is a drift of the swimmer. So why he get the drifted? Due to because of the flow of river. He get drifted. So how much he drifted? X is the drift. So the horizontal distance or drifter of swimmer x is equals to horizontal distance or drift of swimmer is equals to, in general, drift is nothing but what? Drift is nothing but distance, some horizontal distance traveled by the swimmer due to because of flow of water. So then x is equals to velocity into time. So have a look from figure. It is clear that, have a look, the man started swimming by making an angle theta with a vertical line in this direction, and he is reached the other end of the bank at a point D. So let us consider this is a point B and this is a point C. Okay, so he reached the other end of the bank at a point D. He is drifted due to because of flow of water. How much he is drifted? The horizontal distance is x. So distance is equals to velocity into time. What I told you in a previous concept, whenever you are writing the equation for drift, which velocity you have to consider? We have to consider velocity of river with respect to ground. Okay, sir. Velocity of river with respect to ground. But in this case, when he started moving in this direction with this much of velocity, by making an angle theta with the vertical, we got one more component of this velocity in this direction. So what is that? VSW sin theta. So with respect to velocity of river with respect to ground, this velocity VSW sin theta is in opposite direction. Have a look. This is a drift, x is the drift. Okay, sir. So which velocity you have to take to write the equation for drift? So velocity of river with respect to ground you have to take. Have a look. Velocity of river with respect to ground is acting in this direction. But when he started swimming in this direction by making an angle theta with the vertical, there is a one more component of velocity is also there. So what is that? VSW sin theta. So now VSW sin theta is acting on the swimmer in this direction. So VSW sin theta. So now overall velocity is what? VRG minus VSW sin theta into time. So time, what we got? So d by VSW cos theta. So this is what the horizontal distance traveled by the swimmer when he started moving by making an angle theta with the vertical. Are you getting any doubt? Okay, simple concept now. Okay. Right. Have a look. Here I'm writing note number one. I'm taking note number one. So if VRG if VRG is greater than VSW sin theta, if VRG is more, the speed of the velocity with respect to ground is more than VSW sin theta, then this, what happened? Then the swimmer, then is, the swimmer is reached, the swimmer is reached right side of point C, right side of point C. So if the velocity of river with respect to ground is greater than VSW sin theta, then what happened? So this is the more velocity, this is the less velocity. So overall, the person, the swimmer can be reached right side of the point C. He can be reached right side of the point C. Okay, sir. Note number two. If VRG is less than VSW sin theta, then the swimmer, then the swimmer is reached left side of left side of point C, left side of point C. Okay, so whenever this velocity of river with respect to ground is less than VSW sin theta, so it is more, it is less, then what happened? Overall, so the person, the swimmer can be reached the other side of a bank of river at the left side of point C. In this direction he is reached on the other side of a bank of river. Is it clear? Okay, sir. So note number 3. So if VRG is equals to VSW cos theta. So if these two velocities are equal, so velocity of river with respect to ground, velocity of swimmer to water into sin theta. So VSW sin theta into VRG. So if these two components are same, these two velocities are same, then what happened? So the swimmer reached exactly on point C. Then swimmer reached exactly reached exactly on point C. So just he directly reached to the point C. Okay. Any difficulties there? Any problem is there? Right. So pause the video and write the notes. Pause the video and write the notes. 3, 2, 1, go. Let's solve some example based on this concept. Are you ready? Okay. So pause the video and write the notes. I'm going to rub the board. 3, 2, 1, go. Right. So I'm just bring the first question of today's lecture. Okay. So the question is too short na. Only it has 3 plus 3 plus 1, 7 lines only. Okay na. Very short question. Atlunta mantone. Okay. Right. So have a look what they are given. A boat can be rowed at a 5 meter per second in still water. Okay. There is a still water and there is a boat and it is rowed at a speed 5 meter per second. So it is used to cross a 200-meter wide river from south bank to the north bank. Okay, sir. I'm just going to draw the diagram based on given question. Okay. So as we know, this is east, west, north, and south direction. So there is a boat. It can be rowed at a 5 meter per second in still water. It is used to cross a 200-meter wide river. So what is the width of this river? 200 meters. Okay, from south bank to north bank. So have a look. So this is a south direction and this is a north direction. Right. So this is a south bank and this is a north bank of a river. Here is a boat. So the velocity of boat is given how much? 5 meter per second. So the river current has a uniform velocity of 3 meter per second due east. So river current, here we got the new word, river current. So don't get confused. So river current means it is a simply the movement of the river. So river current means what ma? So the movement of river from point to point, one point to another point. So how the direction of the river is changing from one point to another point is called a river current. That's it. Okay. So the river is moving in a east direction. So the velocity of river with respect to ground, how much? 3 meter per second. In this direction it is moving. So what is the first question they are given? In which direction must it be steered to cross the river perpendicular to current? Simply. So in which direction it must? That means the boat is must be steered to cross the river perpendicular to the current. Have a look. Perpendicular to the current means what? Perpendicular to the flow of river. So in this direction the river is flowing. So perpendicular to means this is the perpendicular line. In which direction the boat has to move? And let us consider this is the direction of the boat. So it is making an angle theta with perpendicular to the direction of flow of river. Direction of flow of river. So in this direction the river is moving. For that it is perpendicular line. So with respect to the perpendicular, at what direction this boat has to move? That is the given question. So what is the velocity of boat? Velocity of boat with respect to water in this direction. In a first concept I told you that if the boat or a swimmer has to cross the river over a shortest distance, he must move in this direction. He must move in this direction. And velocity of swimmer or boat is what? Velocity of boat with respect to water. So that's why I'm saying please learn the concept. Please learn the concept, then you can understand easily the given questions. What we have to find, how we have to find. You will get the clarity. Now what is this? Velocity of boat with respect to water. How much? 5 meter per second. What we have to find? The direction. The direction can be given by an angle theta. Direction with respect to the perpendicular. That is what? Theta. So I'm just expanding this line. Okay. So have a look from figure. Solution for a question. From figure, we can write sin theta is equals to what more? Opposite side by hypotenuse. I'm just going to draw this right angle triangle. Have a look. This is the right angle triangle that we have formed. This is an angle theta made by perpendicular line. Okay. In this direction, the velocity of river is there. Velocity of river with respect to ground. How much? 3 meter per second. And in this direction, the velocity of boat with respect to water is there. How much? 5. What we have to find? In which direction the boat is moving with respect to the perpendicular. With respect to the perpendicular. That means we have to find an angle theta. For that I am taken sin theta. So from this right angle triangle, it is clear that sin theta is equals to opposite side. The side which is opposite to theta. So what is that? 3 divided by what is hypotenuse? This is a hypotenuse, that is 5. So we got sin theta is equals to 3 by 5. Sin theta is equals to 3 by 5. So 3 by 5 can be written as sine of 37. So what is the value of sine 37 degrees? 3 by 5. So sine cancel out and theta is equals to we got 37 degrees. From this it is clear that the boat must be steered to cross the river perpendicular to the current at a 37 degrees. At a 37 degrees. So we got a theta is equals to how much more? 37 degrees. Okay, sir. Now, what is the second question they are given? How long it will be take to cross the river in the direction perpendicular to the river's flow? So, they are asking what is the time taken by this boat to cross the perpendicular flow of the river. So, for the time, we have the equation. So, what is that? Time t is equals to distance by velocity. Distance by velocity. They are not asking the minimum time. So when they are not asked the minimum time, then which component you have to take? So t is equals to distance. What is the width of the river? 200 meters divided by velocity. So the perpendicular component for velocity of river with respect to ground we have to take. So the perpendicular component means what? This is 5 along theta side. 5 cos theta is equals to how much? 37 degrees. So this velocity component we have to take. So what is that? 5 cos 37. So what is the value of cos 37? 4 by 5. Cos 37 value is how much more? Cos 37 degrees. 4 by 5. 5 get cancelled out. 4 5 is 20. 0. So t is equals to 50 seconds. So right. Question C. What they are asking? In which direction must the boat be steered to cross the river in minimum time? In which direction? In which direction this boat has to move to cross the river in minimum time? To cross the river in minimum time. Have a look. So here is a boat at a point A. So this is what? 200 meters wide river. Now the boat has to cross the river in minimum time. In minimum time. If this boat moves in a straight line path. If this boat moves in a straight line path. then it takes a minimum time. Then it takes minimum time. So here we have theta is equals to 37 degrees. So if the boat moves in a straight line path, if the boat moves in a straight line path, then it takes minimum time. Then it takes minimum time. So what is the direction of boat? What is the direction of boat along this straight line path? Theta is equals to how much? 0 degrees. If it is moves by making an angle 0 degrees with the bank of the river, with bank of the river. So they are asking minimum time. They are asking minimum time. T minimum. What I told you, whenever you are finding the minimum time, then we can write distance by velocity. Which velocity you have to take? Boat velocity. Which velocity you have to take? Boat velocity. So velocity of boat with respect to water. How much more? 5 meter per second. So what is the distance? 200 meters. So 200 divided by 5, that is equals to 40 seconds. So how far will it drift? How far will it drift? They are asking drift. So drift means what, ma? So this is drift. X we have to find. So x is equals to what? Velocity into time minimum. So whenever we are finding the drift, which velocity we have to take? We have to take velocity of river. So what is the velocity of river? 3 into minimum time. We got 40 seconds. So 340 is how much? 120 meters. So that's it. So this boat has drifted 120 meters from perpendicular line or vertical line. Okay. So likewise, you have to solve the problems. Okay. So pause the video and write the solution. 3, 2, 1, go. Question number 2. So what they are given? So they are given a river. So the width of the river, let us say 30 kilometers. So this is the width of the river. And this river is moving with a speed 8 kilometer per hour. This river is moving in this direction with 8 kilometer per hour. So now from the point A, let us consider this is a point A. So from point a swimmer started moving with a velocity. How much? Velocity of the swimmer given. How much? 10 kilometers per hour by making an angle 37 degrees with a horizontal line. 37 degrees with horizontal line. Okay. So now what they are asking? The time taken to cross the river. So we have to find the time taken to cross the river. So solution A. So what we have to find? Time taken to cross the river. So in general, time is nothing but what, ma? Distance by velocity. Distance by velocity. Then time t is equals to what is the distance here? Distance is nothing but width of the river. So that is 30 kilometers divided by velocity. What is the velocity component we have to take? We have to take the velocity component of swimmer. That is perpendicular to. That is perpendicular to what? Velocity of river, that is perpendicular to velocity of river. In this direction, the velocity of river is there, that is 8 kilometer per hour. So now perpendicular component, have a look. This is what velocity of swimmer along theta side. Along theta side, you will get Vs, velocity of swimmer. How much? 10. Okay, so I'm just writing directly along theta side. 10 cos 37 and perpendicular to this 10 sine 37. That's it. So now which component we have to take? We have to take the perpendicular component. We have to take the perpendicular component. What is that? 10 sine 37. Okay. So time t is equals to distance by 10. Sine 37 value is how much, ma? 3 by 5. So 5 ones are 5 twos are 2 ones are 2 15s are. So 3 ones are 3 5s are. Okay. So t is equals to how much, ma? 5 seconds. So t is equals to 5 seconds. So the time taken by the swimmer to reach the other end of the bank of a river, how much? 5 seconds. Next, at what point does he arrive? At what point does he arrive on the opposite bank? So at what point he has to arrive on the opposite bank? They are asking. So D. So have a look. So here is a person. He started moving. He started moving by making an angle 37 degrees with the horizontal line. So with a velocity 10 kilometer per hour. This is what velocity of swimmer. Okay. Now at what point on the opposite bank of a river he arrived? They are asking that. So let us consider at a point D he is arrived, and from the vertical line he is drifted at a distance x. Let us consider. Okay. So then x is equals to what, ma? Drift x is equals to what? Velocity into time. So what is velocity? Which velocity we have to take? We have to take velocity of the river. But have a look. Here we have the velocity of river is in this direction. Velocity of river is in this direction. Here one more component of the velocity is there, that is in this direction. Have a look. This is also one of the horizontal component of velocity, that is 10 cos 37 along theta side. Along theta side. Now we can write V r minus 10 cos 37 degrees into time. What is the time we got? 5 seconds. So that is equals to, what is VR? VR is equals to 8 minus 10 cos 37 value is how much, ma? 4 by 5 into 5. So 5 ones are 5 twos are 2 fours are 8. So we got 8 minus 8 into 5. So what is 8 minus 8? 0. 0 into something, 0. Big 0 we got. So drift is equals to how much? 0 meters. So drift is equals to 0 meters means, drift is equals to 0 meter means there is no drift. That means he started at a point A and he is reached on the other side of a bank at a point B directly. Okay, that means he reached the other end of a bank of a river at a shortest distance. There is no drift. There is no drift. Are you getting? So this is our answer. So what is point C they are given? C. What is the actual distance? What is the actual distance? So there is no drift. There is no drift. X is equals to 0. He has to reach the one end of the bank to another end of the bank over a shortest distance. That is how much? 30 kilometers. Now what is the actual distance traveled by the swimmer? 30 kilometers. That's it. Any difficulties there? Easy problem now? Okay. Let's see solve that problem. Okay, sir. Right. So what they are given? A person swims at a 135 degrees to current of a river. What I told, current of a river is nothing but simply the direction of river. So have a look. I'm taking the bank of a river. So this is one end of the bank of a river. This is another end of the bank of a river. Here is a swimmer at a point A. Okay. A person swims at a 135 degrees to the current of a river. So let us consider this is the direction of the river, velocity of river with respect to ground at a 135 degrees. Have a look. So this is what, so this is the direction of velocity of river with respect to the ground. So with respect to this is moving at a 135 degrees with the direction of current of river. Are you getting? In this direction, the velocity of river is there. Now this person swims at a 135 degrees with the velocity of river with respect to ground. So what they are asking? To meet the target on reaching the opposite point, to reach the opposite point, the ratio of person's velocity to velocity of person swimmer, okay now, to river water, velocity of river, velocity of river, velocity of swimmer to velocity of the river is equals to how much they are asking. As we know that this is what velocity of river with respect to ground. If the swimmer swims in this direction, then this is what velocity of swimmer with respect to water. Already in a first concept that we have discussed. So what we have to find? We have to find the ratio of velocity of swimmer with respect to water to velocity of river with respect to ground. Okay, sir. Now to find this ratio from this point to this point, what is the angle? 135 degrees. Then what is the remaining angle? 45 degrees. What is the remaining angle? 45 degrees. Just along theta side. Along theta side, we get VSW cos theta and perpendicular to this VSW sin theta. What is the angle here? 45 degrees. Here also the angle is 45 degrees. So what we got? Have a look. VSW cos theta, velocity of the swimmer with respect to water is in this direction and velocity of river with respect to ground is in this direction. So these two are equal but opposite in direction. So therefore VSW cos 45 degrees is equals to velocity of river with respect to ground. Now what we have to find? We have to find the ratio of velocity of swimmer with respect to water to velocity of river with respect to ground. Just bring this term to this side. It becomes velocity of swimmer with respect to water divided by velocity of river with respect to ground is equals to 1 by cos 45. What is the value of cos 45? 1 by root 2. If root 2 comes to numerator, so VSW by VRG is equals to root 2 is to 1. That's it. Simple problem now. Any difficulty is there? Okay, sir. Right. So have a look. Example number 4. So what they are given in this direction, the velocity of river is there. Velocity of river with respect to ground is 3 kilometers per hour. And here is a swimmer. He swims in this direction with a speed 6 kilometers per hour. So the width of the river's bank, how much? 2 kilometers given. So what they are asking? They are asking to find time minimum. Simply T minimum is equals to what now? Distance by velocity. Distance by velocity. What is the distance? Distance is nothing but width of the river divided by velocity. They are asking minimum time. They are asking what now? Minimum time. So now we have to find the velocity. Which velocity? Perpendicular velocity we have to find. Have a look from this diagram. So what is this? Velocity of river with respect to ground. And here is a person and he gets started swimming in this direction. Okay, right. So what is that? VSW is equals to 6 kilometers per hour. Now what we have to find? We have to find this velocity, perpendicular velocity. Are you getting? This perpendicular velocity we have to find. So velocity of river with respect to ground is equals to how much? 3 kilometers per hour. Now what we have to find? This velocity we have to find. Okay, right. So VSW is equals to 6 kilometer per hour. Velocity of river with respect to ground is how much? 3 kilometer per hour. So what is this? Velocity of swimmer with respect to ground. This we have to find the perpendicular component for the direction of reverse flow. Okay, so this is a right angle triangle. Okay, so from this right angle triangle, VSW hypotenuse square is equals to side 1 square plus side 2 square. What is that? VSG whole square. What we have to find? The perpendicular component, that is VSG whole square, that is equals to, if this term comes to this side, it becomes minus. So VSW whole square minus VRG whole square. So VSG whole square is equals to VSW whole square. So what is that? 6 square minus VRG whole square. So what is that? 3 square. 6 6 is 36. So 3 3 is 9. 36 minus 9. How much more? 9. 27. 28, 29, 30 plus 6. Okay, right. So 27. If square went to that side, it becomes VHG is equals to root over 27. So what is the perpendicular component we got? Root over 27. Just substitute here, root over 27. This is what? Minimum time. That's it. So this is our answer. Any difficulties there? Easy problems now. So please learn the concept, then you can understand how to do the problems easily, right? Okay. So pause the video and write the solution. Pause the video and write the solution. 3, 2, 1, go. Right. So the question number 5. Have a look what they are given. A boat moves perpendicular to the bank with a velocity of 7.2 kilometer per hour. Solution. So there is a boat and which is it moves perpendicular to the bank of a river with velocity of 7.2 kilometer per hour. So it is moving perpendicular with a velocity of boat. How much more? 7.2 kilometer per hour perpendicular to the bank. So the current carries it 150 meters downstream. So the current carries 150 meters downstream. So what is this? So in a river, boat problems, I explained that. Downstream. What is the meaning of downstream? So the distance traveled by the boat in the direction of river flow. In the direction of river flow. Then it is called what more? Downstream. So this the current carries it 150 meters downstream. That means this boat is drifted. Drifted. X is equals to how much? 150 meters. That's it. Answer is over. So find the velocity of the current. Find the velocity of current. Current means velocity of river with respect to ground is equals to how much? That's it. Use B is equals to 0.5 kilometers. So width of the river is given how much? 0.5 kilometer. So what we have to find? Velocity of river with respect to ground. So to find the velocity of river with respect to ground, from the formula of drift. So what is drift? D-R-I-F-T. Drift X is equals to what, ma? So velocity into time minimum. Okay. So what is the velocity? Velocity of river with respect to ground into T minimum. We have to find. Okay. So how can we have to find the time minimum? So time minimum is equals to distance by what? Distance by perpendicular component of the velocity to velocity of river. So what is that? Velocity of boat. So distance is nothing but what? 0.5 kilometers width of the river divided by V perpendicular 7.2 kilometer per hour. So kilometer cancel out and point cancel out and you will get 5 by 72 hours. So just convert 5 by 72 hours into seconds. Okay. So T minimum is equals to 5 divided by 72. So hour, 1 hour is equals to 3600 seconds. So if you solve this, you will get 250 seconds. So T minimum is equals to how much more? 250 seconds, right? What we have to find? We have to find velocity of river with respect to ground. So X is given 150 meters. So we have X is equals to velocity of river with respect to ground into T minimum. So what is X? X is equals to 150 meters. That is equals to velocity of river with respect to ground into T minimum is equals to, we got 250 seconds. So 0 0 get cancelled out. So 5 3s are 15, 5 5s are 20. From this, velocity of river with respect to ground is equals to 3 divided by 5. That is equals to, so 5 ones are 0, 0.30 is there, 5 ones are 5 6 are. Okay. So meter per second. So velocity of river with respect to ground is equals to how much more? 0.6 meter per second. Okay, na? Any difficulties there? Easy problems now. So once if you are understood the concept, then you can do any problem like this. So that's why I'm taking the more time to explain the concepts. Okay, right. So have a look. What is the next problem they are given? A swimmer is capable of swimming 1.65 meter per second. So the velocity of swimmer is given. So in still water, if she swims directly across a 180-meter wide river, so they are given width of the river. How much? So 180 meters. So velocity of swimmer is also given. Velocity of swimmer with respect to water given. How much? 1.65 meter per second. Right. Whose current is 0.5 meter per second. Whose current means what? The direction of flow of river. How much? So velocity of river with respect to ground. How much more? 0.85 meter per second. So how far downstream from a point opposite her starting point will she reach? So what they are asking? How far downstream? How far downstream means? So they are asking X. So downstream means what, ma? The object or the boat or the swimmer. So moving in the direction of flow of river. Then the distance is called what? Downstream. They are asking downstream. We have the all values. Then what we have to find? We have to find the drift. X is equals to how much? So this is your homework problem, and you will get the answer 92.7 meters. You will get the answer is 92.7. So try the problem and you will get this answer. Then whatever the process you are made, that is correct. Okay. Right. So pause the video and write the solution. Pause the video and write the solution. 3, 2, 1, go. Right. So this is the end of the today's lecture, and with this lecture, all the concepts based on relative velocity are completed. So we will meet on our next lecture. So from next lecture onwards, I am going to start our projectile motion, right? So we will meet on our next lecture, and it's time to say signing off. And this is Rakesh Kanganti signing off. Jai Hind.